thank you, my company Tata Technologies, for providing me an opportunity to moderate these sessions. And this session is for smart manufacturing as well as digital twin. Now you know that in 1990s, typically the CAD/CAM and PLM are the buzzwords, but now it is must as a part of industries. And nowadays in manufacturing industry, the term called smart manufacturing and digital twin are the buzzwords. But we would like to know from the industry experts that what are these terms and how these are benefited to the industries. So to start this session, I would like to ask Punit, what is the smart manufacturing as compared to traditional manufacturing?
Sure. Thanks for the question, Naren. And I would like to start first from the word smart, right? What does smart means? Actually, smartness is nothing but to think, analyze, and make right decisions. And that's what we are trying to do with smart manufacturing. We are enabling the traditional manufacturing process by using the state-of-art technologies so that way they become eventually smart. And how can we do that? I think the first and foremost is connectivity. We are leveraging IoT so that way machines can be connected with each other as well as with the clouds so that way they interact with each other. We are monitoring the data. We are using sensors to gather the data, and then we have devices which can store the data. Once you have the data, then you can use the power of AI to analyze the data and make right decisions. Some of the examples that you all have come across is like quality control, inspections, predictive maintenance. We just talked about it. And who can forget about the industrial automations, right? The robots used in our shop floors performing different tasks like welding, soldering, and assembling the entire product. So this is how I would say the smart manufacturing is trying to transform the way we used to do traditional manufacturing.
Yeah, thanks, Punit. But I would like to know the challenges, especially the industry which has got a legacy system, right? And in traditional manufacturing, is it not a smart manufacturing? Then what are the challenges which are being faced? And typically in the legacy system, so Mukesh, if you can start with, and then Shreeyash, you follow with your views as well.
Sure. First of all, thank you, NASCOM. Thank you, Atlas Copco, for providing me this opportunity to be part of the panel discussion. And what I have experienced, because when we were implementing in certain places the smart manufacturing systems, the first and foremost is setting up clear expectation. There are two aspects that we need to understand. First is the behavioral, and the second is technological maturity. On the behavioral side, if I understand the expectation from the top, we want to implement smart manufacturing, but what problem are we going to solve? If that is clear, then the problem gets very simplified. And often this should not be seen like, is it a threat to my own existence if I'm a worker on the shop floor? Is it going to be a threat? So the very important point is to have buy-in from the people who are going to implement and take them as part of the project, because that's very important, and that's where sometimes it's really difficult to get the decision from the top get directly implemented if you do not have the buy-in. And the way to come to this buy-in is we have a set of people. We cannot actually replace these people, but what we need to do is upskill and reskill them to get the adoption on the technology to make sure that we are able to implement in the right direction. Another problem that we were also facing is, do we want to take small steps or do we want to take the large leap? Because often there is a challenge. It's about the maturity of the organization. Are they capable of dealing with the large transformation? And we have seen that, okay, small steps leads into the better outcome, and it brings much more value. So yeah, then also you can build the maturity. And final, which is last but not the least, is what kind of technology stack would you like to use? So if I would like to track my assets, I don't want to use GPS, I want to use beacons. And if I want to do the diagnostics, I need to understand how much data do I need to ingest or the frequency of the data, because that will define your cloud capacity. Right? So all those decisions need to be made before we take into the journey on the smart manufacturing.
Shreesh, your views?
Yeah, thank you, NASSCOM, for the opportunity, and thank you for bearing with us, everybody. My take on it is, since Mukesh, you talked about more of a change management and adoption as a people perspective, I would like to share 2 to 3 points on the technology adoption point of view. Because whenever we talk about smart manufacturing, the approaches are probably, in my world, there are 2. You have a business problem, and from that you want to adopt smart manufacturing. The reverse is, you have a technology available, and then you see how I leverage that technology towards smart manufacturing. So in both the cases, the technology adoption or the way you adopt technology in your organization plays a key role. Because many times I have seen we have a technology fantastic as a point solution, but it does not integrate with our legacy or so-called traditional systems. And sometimes we tend to adopt it without thinking of that. So that is something, a technology-oriented challenge, which eventually triggers the technology change management as well as the acceptance of the system perspective. So that is a major challenge I have seen. Eventually, then the infrastructure readiness, the data readiness. Sometimes there is a data available for your smart manufacturing systems or solution, but that is not digitally processable. So I have had instances in past where one of our stakeholders saying that we have data in digital format, but they have shown me a scanned papers of quality control, which may be not immediately available for digitally processable solutions, or it was not available immediately for digitally processable or any of further use. So I think that I would like to add over and above what Mukesh said.
So thanks, Shreesh. But while organization would like to go for smart manufacturing, how any organization can measure the ROI around implementation of smart manufacturing? If you can touch upon that, that would be good.
Yeah, so it has been always a debate on ROI when it comes to smart manufacturing, digital twin, or any kind of digital innovation. So I would, again, in my world, there are 2 approaches which I have already touched upon, is TAB versus BAT. Just to remember very easily, I have just had a short form. TAB stands for Technology, Application and Business, and BAT for Business, Application and Technology. So either whichever way you want to start, that ROI depends on that. Whether you have a business need, then from business need, you try to find out what application I will use to solve my business need, and eventually scout for technology to develop that application. That's the BAT approach, BAT. And the reverse approach is the TAB. When you already have a technology like AI, AR, VR, maybe femtophotography, and so on and so forth, and I have a technology available, then what all applications I can develop over it to solve different problems which I have today. So depending on both the cases, the approach of ROI will be different, but eventually it will come down to certain tangible ROIs and certain intangible ROIs, in my opinion. So the tangible ROIs are no-brainer. Either you save cost, time, or add some differentiation to your product, right? Or sometimes people even thought of another way, I don't know, I'm sure you might be knowing it, called HBB, hours back to business. So either you are not saving cost as such, but you are giving back hours saving to your business, which the hours saved can be further utilized in terms of producing more or producing effectively, linking to cycle time. So that's one part. The intangible benefits also have to be taken in consideration when it comes to ROI, because the smart manufacturing or smart solution also brings in the culture of collaboration, the culture of thinking digital, the culture or a psyche to think data which can support us for further prediction. So I think when we talk about ROI, we try to do it in this way, understand the TAB versus BAT, which way we want to go for this particular implementation, and then calculate the ROI in intangible as well as tangible to support the business case.
So thanks. Tab versus I, BAT is good. Okay, now in the industry, AIML is also playing an important role, right? And we would like to know from Punit that how AIML plays an important part in smart manufacturing. So Punit, over to you.
Sure. I think it does play a very significant role, and I would like to touch upon a couple of examples that we implemented in Eaton, just to give a perspective of how we are utilizing those solutions. And one of the examples that I would like to share over here is from the quality inspection side. So we are using a technique called CVML, computer vision and machine learning algorithm. Both we are kind of combining. And in this technique, what are we trying to do is you take images of your part and then you compare those images with the specs or what is the acceptable criteria. And based on to the compliance, you accept or reject the part. So this is one of the solutions that we implemented for our seals product. And we have accuracy of more than 95% in terms of our exception and rejection rate. Another example I would like to touch upon from the predictive maintenance side, where we introduce a solution for monitoring the health of our motors. And what we are doing over here is we are just measuring some of the electrical parameters. As the machine degrades over a period of time, its characteristic changes. And that's what we are trying to analyze and see if there are any anomalies which we can detect by studying those patterns. So that is another solution that we try to implement for our product in order to see what anomalies getting generated over a period of time, and then can we inform the operator to take corrective actions based on to the what anomalies we are detecting.
Yeah, thanks, Punit. But I remember Tata Technology working with one of the automotive OEM of US, and they spend huge amount of time in carrying out the digital inspection. So typically for any of the body shop, if number of stations are 20, then they have 25 stations to build the body shop. And in the last 5 stages, it will be purely a digital inspections. So it is from the mirror, it is from the scan data, it is from the master data, and all the aspects of the defects are being captured at each stage, and the machine learning model is tuned to take all those defects while the next set of body is getting assembled. So I hope we have a good insight on the smart manufacturing part. So let me go to the second buzzword, that is the digital twin. So people would like to know that how it is different from the conventional CAD model and what are the benefits out of digital twin. So typically digital twin falls under the product, process, and in these two categories, the industry is working on these areas. So we would like to know from Shreeyash that what is a digital twin is all about. If you can elaborate how it is different from conventional CAD model, how it is helping industry in terms of their KPIs, whether it is a warranty, whether it is a performance, whether it is optimization of manpower on the shop floor. So
as all of us might know, digital twin in a simple word or layman's language is a digital version of your physical component, system, product, or a process, or it can be as good as a digital version of your factory, which we call it factory twin. So this is something a typical understanding is, but the digital twin can go much more beyond that. And if I have to categorize, as you already categorize, I would categorize a design twin, process twin, and a factory twin. And there is another term called service twin, which we are exploring in nowadays, and also an asset twin. Asset twin is nothing but your digital replica of your machine, which is already in action on your shop floor. So these are the typical digital twins we've actually worked on. And so design twin, especially, I want to pick up the thread from you, Naren, as a performance or warranty. So if you have, imagine a component which is already in the field, having designed for 50,000 cycles, for whatever reason, that may be a flywheel, that may be a gear, or any component which is completely into dynamic operation, right? So a 50,000 cycle it is designed to. So imagine if we stop that component at 20,000 duty cycle, and there are some deformations and there are some changes in that component which was designed as when it was manufactured new. So we take back, we convert that the same component into a digital environment, into CAD, and then we compare it with the original. So as manufactured versus what happened after 20,000 cycle. And if it is a correlation between dimensions and dimension deformation and the duty cycle, we try to set up a correlation and see if similar load or similar duty conditions are applied till 75,000 cycle, 50,000 cycle, is it going to fail in some cases? Is it going to deform further? And then what you do, you understand that and eventually add your optimization on the digital twin, which is converted from the physical component, and change the dimension, change the radius, change the lid geometry here and there, and again subject the same component towards a CAE or a simulation and check. So that way it reduces. So what the insight we get usually is, we get an insight that how much it will last. So if it is lasting more than my warranty, then I'm overcommitting my warranty and I have an opportunity to optimize my design, because I have declaring it at 50,000, but my component is lasting till 75,000. Now take a reverse case. If my component is failing before 50,000 and I'm committing 50,000 with that ecosystem or that area of application where the component is being used, then I have to optimize and make sure that it lasts for 55,000 duty cycle so that my warranty costs are reduced. I mean, just an example where I have picked up the performance warranty one part. But in a nutshell, what I would say as a benefit, why we do any twin in my world again, and I'm just throwing my perspective. I would like to explain in simple thing why we do digital twin of any sort, be it design twin, process twin, or factory twin, is for RIP or RIIP. So it's maybe synonymous to rest in peace, but R stands for relationship. Whatever design twin we would do, be it process, design, or factory, we're trying to establish a relationship between phenomena, process, object, or asset. Why we are doing that? With the relationship, we are trying to get more insight about happenings, phenomena, and actual real field events. Then relationship to insight. And when we have insight, we try to innovate. That's the second I. And the last P is all of why this R, I, and I is to predict and take right decisions. Again, be it design twin, process twin, or factory twin, eventually all it will lies in RIP. So we don't rest in peace, but our decisions rest in peace.
Yeah. But please remember that it is not RIP, RIIP.
Yeah. And that's copyright from me.
Yeah. Good. So, see, typically what he talked about digital twin, in which design paternity will have challenges in terms of going back to the factor of safety, going back to the type of load conditions which they are applying for their product, because digital twin will bring back to the design fraternity in such a way that it will have optimization at a first level, and this is going to be a challenging even for design community here afterwards. But there is one question that everybody would like to carry out the digital twin at a real time. Now, how that synchronization of real time synchronization happens with the digital twin as compared to digital twin to the physical data. So Punit, you would like to cover that part of that?
Yeah. I think that there are multiple steps involved when we are talking about the synchronization of a physical part with its digital asset sitting there, right, somewhere. The first and foremost is that collecting the data, right? So I should have a data collection. We should have a sensors which can sense, monitor the data which is getting generated. Then I should have an IoT enabled device for the data storage. So that is the first and foremost steps, that we are monitoring the data, we are recording it. Then the next step is the data transmission. So we will be sending that data to somewhere, so that way it can get processed. So high speed communications, IoT is the technology that we should be using for that data transmission, that will be happening as a second step. The third step in the process would be a data processing. So I should have an algorithms which can process the data, so that way I will filter unwanted content from the data, and I will have only the data which I want to use it for further usage. Once I have that input data ready, I should also have a digital model, which is a digital replica of my physical asset, which will take that input and then try to run analytics onto that. So the most critical piece is the model, which we are calling as an digital replica, should have a high level of maturity. I should be able to trust what results it is getting out from that model. And also that model should be executing the results very fast, right? I can't wait to see the results, right? So we can use some sort of a technique called reduced order models, where we just feed in the inputs, and that reduced order models will fetch us the inputs or the outputs in a very quick turnaround time. And last step would be, once I have the output ready, how should I feed it back to the physical asset, so that the required actions will be taken. So those are the steps that we can use in order to have a synchronization between a physical asset with the digital.
Okay, thanks.
I would like to add, with your permission. So, talking about data in digital twin, if you take a process twin, real-time process twin, then what happens is, again, in my world, we have set up a framework for data. Unless those frameworks are checked, we are not going ahead with the process twin, especially on data side. So when you talk about data from the perspective of process twin, real-time, first thing is the volume of data. Second is the velocity of the data with which it has to capture to have a real-time process twin. Third is the value which it will bring in. So variety, value, volume, and velocity. So those things we are, and important, last but not the least, is the trustworthiness of that data. So if all of this is not checked, what value the data is bringing in real time, what velocity, what volume, and what value, all of these are not checked, we are not, in a way, the sort of a guardrails for us to not go beyond or further on process twin.
But do you think that industry will demand for faster implementation of digital twin when their existing problems are on the shop floor? Do you think that that is happening?
Yes, that's happening, and that's what probably the digital twin get divided into these sub-segments of, unless you don't aspire to have a full digital twin closed loop into your factory level, right, from product to your enterprise level. Rather than, what I have seen, there is an adoption of design twin separately, then a process twin separately where there are problem or tethering problem lies, and eventually they get there by collaborating or connecting all of this together.
Yeah, I think also, just to add upon on that, is to make sure that there is healthy exchange of data between design twin, manufacturing twin, and also the service twin, because it has to circle back into the system for the benefit of customers, end users, and also for the society at large, because you can then improvise products on the energy efficiency and bring benefit to society.
Thanks, Mukesh. So we talked about the ROI on smart manufacturing, right? But industry or the participant definitely would like to know what are going to be the ROI if I invest into the digital twin. So Mukesh, if you can share your views on that, and then followed by Shreeyash.
So what I think the first thing is, and I have a use case where we said, okay, the first and foremost thing is I would like to make sure, because when the industrial products are going into the field, the critical success factor of such industrial product is uptime. How do you guarantee the uptime? Like Punit, you said, the degradation of the life. So we need to understand the prediction of the machine, that okay, what is the remaining life, I would say, or how much useful life has been still with the machine. So if we can predict that, there is possibility. And on the similar lines, even when we talk about digital twin, there are multiple levels of digital twin, like virtual twin. It's just like a CAD model. Then you infuse energy or the physics model into it, and then it can give you the output or predict the outcome of that. Then prescribe, that's the next level, that okay, if this is the situation, what would have failed in my system? So that's a prescription level. And the final is the autonomous level. Depending on each level of the digital twin, it brings much more value on the table. And then one of the use case that I'm having currently is the Global Diagnostic Center. We have close to 15 people who are working 24/7 to monitor around 250,000 machines worldwide. And the AI algorithms were put onto the data. So edge computing gives the data back into the cloud, and then from cloud the AI algorithms are put into that. So you can actually identify which are the machines which are having trouble. It might be there is a high temperature, but is that really the situation because it is not at the very off conditions, or is it because the performance is not coming up? And then the AI can detect the smart event with the help of smart event, that okay, what's happening, and on that the person can analyze that okay, is there a problem or not, and this team can then alert the nearest service team and make sure that uptime is guaranteed. So these kind of solutions can be practiced in a much larger way and feedback into the design team that okay, what could be the best design parameters.
Chris, your views?
So again, speaking about again ROI on it, I would say especially when you talk about digital twin, it is a case specific ROI, I would say, unless it is already at a level of enterprise. Because if you take the warranty, it's a straightforward example. If I'm able to reduce 1% of my warranty cost today, I think it serves a business case depending on the volume of my production or the customer complaint. So second could be a performance related, which is a direct input to designers. So you're taking a field component and then converting that into a digital twin, are able to do an interim innovation and see where are those improvements. Because sometimes it is designed for a purpose but not designed for a point of application, right? So where your product will go, and typical case is our EVs. Now everybody knows EVs are in thing, but how many companies already have a data and experience about what they call it as IPVT, right? Incidents per 1,000 vehicle. So how our motor will perform in Himachal Pradesh versus how our motor will perform in South India, that data we really don't know. So we really need to intervene with these techniques and concepts like this to understand faster and again go back to our RIIP and solve our problems to have better and better ROI in a way. I think digital twins benefit is directly towards the business. You take it design twin, process twin, or a factory twin. I will cite an example. In a heat exchangers, in oil and gas, you have multiple heat exchangers in a series. And if you have a real-time process twin, you will be exactly able to know with a correlation after so many cusecs of discharge of the oil or fluid, what is the residual deposition inside those pipes. And you can take exact timing to have a planned downtime. So if you have a next process which is like 25 lakh cusecs of discharge through my 4 heat exchanger, I would exactly know whether to take right now so the 25 lakh discharge is critical for me, or I can stop it in between and do that maintenance and take out all the residuals. So I think in these particular cases, the ROI is very straightforward, very tangible, very frugal as well.
Okay, thanks. But see, three of you are industry expert in your industry. We would like to know the use cases, successful use cases from each one of you, so that the participants here will understand that how the digital twin is implemented, and hopefully they will get some inputs from you so that they will start thinking in that direction also. So Mukesh, if you would like to start with you.
Sure. So one example, Global Diagnostic Center that I explained, because then it leverages value, customer experience improves. But the very important, like you said, from the business point of view, business case, so when we are manufacturing any machine, and obviously there are the tolerances play very important role in the performance. Now, if you do the testing of those machines with a different tolerances, and if you combine those data, you can put kind of an algorithm that, okay, if the manufactured machine with so and so tolerance, how will it perform in the field? And we built kind of modules for the component, and when we integrate those modules into the physics, the system that we have built, we are able to predict that, okay, this is what with this tolerance the machine is going to deliver at the site condition. And sometimes if your controlling parameter is only 1 or 2, it's very easy to find out on a XY chart, right? But if you have 7, 8 dependable parameters, imagine it's even not possible to put it into the perspective of graph and predict that, okay, what will happen. And there AI can actually, or digital twin can actually help us get, okay, what will be the performance if you have inlet temperature so and so, if you have environmental conditions so and so, if you have oil temperature so and so. So you understand, that is the real time solution that we can get, and we can confidently say that, okay, this is what it is going to perform.
So here in this case, the performance of machine have improved.
Yes,
Yeah.
performance of machine has improved, and then you can also improve the design, because when you understand that, okay, these are the parameters which are influencing. Some parameter will influence very slightly on the edges, but some parameter will influence heavily. So then you know what are the critical components. Whether do I need to provide chamfer at particular edge, yes or no, whether I need to understand that, okay, the tolerance at this level is good to relax and tolerance at this level is important, and that's why you can actually improve the machine, but also the cost of the product.
Punit, you would like to share
so-
your
Sure. So
assessment?
one example I already talked about it, which was on to predictive maintenance, mostly a motor health monitoring. I would like to touch upon one more example that we implemented. It's on our product transmission, a gearbox for the vehicle. And the solution we call is an Eaton IntelliConnect. What we are trying to do over there is we are monitoring, real-time monitoring the faults that is getting generated in the vehicle. And then we are recommending a troubleshooting solutions to our fleet owners. Apart from the solutions, we are also kind of suggesting them the severity ranking of that fault, so that way they can take a corrective actions accordingly when they need to schedule their planned maintenance. And this has certainly helped in terms of reducing their unplanned outages that used to happen for their fleets. So this solution is what is helping.
Thanks, Shreeyash.
Yeah, so I can give one example and one analogy since we have time. So one example, we all know that in aerospace machining, the machining parameters and GD&Ts are very tight, stringent, right? So it calls for a solution where it is the machine is online correcting the speed, feed, and other parameters. So that every time you whatever manufacture falls into a prescribed GD&T and falls into your regular quality CP/CPK and normal distribution. So what we have tried in past is that you have a process twin where you have a continuously monitoring the measurement of the component which is being machined. Yeah. So you have parameters like the dimension of that component which is being machined, the dimension of the tool which is cutting that, and the machine vibration, the machine temperature, coolant temperature. What happens every time there is a signal going forward and you are creating a process twin and checking it, and once you have that relationship built and the correlation, then you developed a AI-based program or a regular rule-based program with diffusion or discriminant analysis and whatever tools, the techniques are available. Then the machine is automatically correcting its speed, feed because of its wear and tear of tool, wear and tear of the component itself, the chip formation, the temperature of the coolant, and eventually try to have a component out of that machine falling into a stringent GD&T. That's one. And I could simply, extrapolate this to an analogy. We all have seen team sports, football, basketball. What usually the coach does there, it might sound a story, but I strongly relate to that. He has a template of that ground, and he looks at the player where my team is playing against what opponent, and who is playing what and who is stronger at what position from the opponent side. And he quickly creates some positioning on that template, be it basketball or be it volleyball ground on a marker slate, right? And then he teaches or try to teach his teammates how you can play. I think that's a physical digital twin, or a so to say they are modeling it into a temporary way to promote and solve the problem for upcoming event so that we can win the match. I think that's an analogy very well fitted in you can forget the aids because we are converting everything into digital. Here we are converting everything into digital of people mind as in imagination, right? And then we are trying to solve how to win the match.
Yeah, even we saw this in soccer matches and hockey matches where the coach tried to replicate that on the board. Yeah, we have 4 minutes, so I would ask any participant have any questions to ask to our industry leaders.
Okay, what will be real life case for digital twin in our day-to-day life?
Google, everybody use Google Maps. That's the real life digital twin. The moment you change the path, it tells you that, okay, this is the corrected path. So that actually physical map is translated into digital map.
I think I can add an interesting story if we are okay. So imagine, how many of you have come here by car? Just raise hand please for me. Quite a few of us, right? And I'm talking, this is a disclaimer that I'm not talking about this hotel in general. So people, when you enter into this hotel or any hotel, especially for this conference, they open up your boot, right? And a hood or to see what is there. I always ask this question to them. Have you seen earlier a bomb or a dangerous thing earlier so that you can benchmark? Right? The answer is no, usually. And don't worry, I'm not talking about this hotel. So, but I always ask this question to them, have you equipped with that data, and to answer your question, have you equipped with that, how does things look like to benchmark? How do you identify whether there are 4 wires coming out of my battery, then my vehicle is suspicious, or there are different wires which are unusual than the regular car? How do you identify? How many images they will store in their mind, right? So imagine a solution where they are equipped with a tablet, and then when the car comes in, he or she is scanning it, and that goes back, and all the physical, maybe, sorry to use this kind of words, but detonators, bombs, C4 or whatever dangerous equipment that has a threat, as a social threat, then that images are already captured. So it scans the bonnet, or sorry, not bonnet, the engine bay, and creates a digital twin to compare with the data what we have registered and try to go near to that and actually immediately give the signal to the security guard saying that I think this feels suspicious. A human can remember such a limited way that way, right? On the spot. So at least this could be a real life example where digital twin can save lives that way. Because many of the time, unfortunately, they have not seen the variety of the dangerous things and they are inspecting the things.
Yeah.
So I think that would be a real case in my mind.
Yeah, please.
Yeah, my name is Ajay. Thanks for the fascinating insights and fabulous analogies. Shreeyash could quickly relate to all the examples that you gave. Generative AI is the new thing which is again making waves across the industry, and I'm sure that as heads of your own functions and domains, you would also be looking at the technology. Would be interested in knowing your thought process, how your organizations are leveraging or planning to leverage this new technology for manufacturing, smart manufacturing purposes.
Would like?
Yeah. So just want to add on to that, right? How as an industry we are trying to use generative AI, right? What in Eaton we are trying to do is we call that as an autonomous design. So the idea is based on to the requirements that we receive from our OEM side. We know these are the certain sets of requirement that a product needs and that we get from a OEM, right? Can I have an integrated platform ready so that way once I know the inputs and we have a legacy of the design insights that how we are developing our product, right? Only from the inputs can we then create the final design model itself, a 3D model, which can go ahead and be used either for 3D printing or can go out, drawings can go out to our suppliers for quotations. So that is something that we are trying to explore more from our side. You can call it an autonomous design, that you don't need a design engineer as per se to design your product once the inputs are out. Or you can also call it kind of a conversational design, right? Like we call Siri, right? And then you keep asking questions, you keep getting answers. So that's how you can imagine that those designs will get evolved once you see the generative AI matures where it stands today.
In our case, what we try to do usually is for us, so for me it's important to have a proven model of AI. It can be anything as per requirement, as he rightly said, whether you want to use a diffusion model, Boltzmann model, autoencoder, or whatever in Gen AI. But the key what we try to do is, so let's say you have a 1 year data of a machine, right? And there are events which is an outcome of that, which is already measured. What we do is we take the first 6 months of data, depending on which proves to be true in our context, and maybe similar you can approach this way, I don't know. But you try to develop a model on 6 months and try to see what my model is predicting. Is it predicting the next 6 months data accurately? I think then that's the correlation I will set for that particular context. And then eventually try, before deploying it to actually in production or even doing testing, I would test in different ways for depending on the past 6 months data, whether it is my model is producing the next 6 month data for last year. I think once that is proven, then you can extrapolate that to any model. So more than an AI model, I would more rely on, on the first proving my AI model.
So in Gen AI, some of the examples in which we are working with automotive OEM is identifying the braking patterns, identifying the tire wear pattern, how it is happening based on the road conditions, different part of India or different part of any of the country. And this is how it is being predicted, as he rightly mentioned, that if you have a data, then take that data and build the model in different zones so that you will get right kind of data in terms of changing of your tires or in terms of getting a patterns of how the user apply their brakes. I think we are out of time. Thank you very much for giving insight on smart manufacturing and digital twin. Over to you.
Thank you so much.